Hi guys, happy Wednesday. Nice job yesterday and the day before starting our new chapter, starting chapter 8 with polynomials and naming them in the various many ways. So today we're going to be moving forward, ultimately preparing us for Thursday, which is like an iconic moment in your math careers because we're going to introduce something in an acronym that once you learn it, it's like you can't unlearn it because it's very specific to algebra. So today we're looking at multiplying and factoring polynomials. So your goals for today is not only to multiply a monomial by a polynomial, but also we're going to talk about factoring and then also just the greatest common factor in itself. Let's quickly review though, just to make sure that we're all on the same page. So remember that we can name polynomials, we can identify the degree, we can name it by the degree, and we can name it based on the number of terms. So when we do that, we've got 4x to the third plus 7. So we know the degree is 3 because that's the highest exponent that we see. The name using the degree, so I know I start with constant, linear, quadratic, and then if it's 3, then it's going to be cubic. All right, and then because there's only 2 terms, that would be a binomial. Bi meaning 2, there's a binomial. For looking at our blue example here, the degree is 2 because that's the highest exponent. If it has a degree of 2, that means that we consider it quadratic, okay? And then because there are 3 terms, that would be known as a trinomial. So you could call this a second degree trinomial or a quadratic trinomial. You can do whatever you want as long as you can identify all components. All right, last one. Because you just have 8x, the degree is 1. Technically, if it's 1, that is linear, because if you plot it, like if you had like y equals 8x, that would just create a straight line. It's only 1 term, so that is going to be a monomial, and you could call it a first degree monomial. All right, now we are getting into our new material. So if I gave you this expression here and I asked you to simplify and name it, sorry, I got scared. Simplify and name it. This is your distributive property, essentially, that's what's happening. So if I grab myself a pen, we're essentially just multiplying each term inside. So you're multiplying everything by this outside term of negative x to the third power. When you do that, so essentially we're using the distributive property here. So negative x to the third times 9x to the fourth, negative 1 times 9 gives us a negative 9. And then ask yourself how many x's you have. So you have x to the third and x to the fourth. Remember, we just add those exponents. So that's going to give me x to the seventh. Then you're going to multiply by the next term here, negative x to the third times negative 2. Negative times a negative gives us a positive. So that'll actually be plus 2. And then with our x, if you've got x to the third and x to the third, that's going to create x to the sixth power. With our last term, if it's negative 1x to the third times 7, negative 1 times 7 gives us a negative 7, and then it's just x to the third power here. After you've got this simplified version, you need to ask yourself, is it in standard form? So I see that it's x to the 7th, x to the 6th, x to the 3rd, so that's good because you have your highest exponents from left to right. Now you can also name it. So identify the degree. Okay, I see 7 is the highest exponent, so it'll be 7th degree. And there are 1, 2, 3 terms, so that's going to make it a 7th degree trinomial. So essentially, you guys, when we're just multiplying and simplifying expressions, it's kind of like using the distributive property. You just need to be cognizant about your exponents and knowing that we need to add them. Let's do another example to make sure that we've got it. So here's your expression, and it's asking you to simplify and name it. Again, this just looks like kind of like an accelerated version of distributive property. So we're going to be multiplying 2x by every piece that's inside of here. So 2x times x to the fifth gives me 2x to the sixth. Remember that this has an invisible exponent of 1. Then 2x times 4x to the second is 8x to the third. 2x times 8x, be careful, that's going to be 16x squared. And then last term, negative 11 times 2x is going to give me a negative 22x. Now to name it, look for your highest exponent. So I see 6, so that's going to be a 6th degree. Because there are 1, 2, 3, 4 terms here, it's going to be a 6th degree polynomial. Okay, because remember, anything over 3 terms, that means that we're going to be using the word polynomial as opposed to like monomial or binomial. All right, second part of the lesson, here we go. Now, I don't know how much you remember from essentially it's probably like 6th and 7th grade with greatest common factor and factoring in itself. But if I give you an expression that looked like this, 2x plus 10, not only could you identify the greatest common factor, but you can also factor out that term and create a more condensed and solidified version. So if I'm looking at the terms 2x and 10, what is the greatest number that's shared between the two and that we could essentially like pull out? So like I know with 2, the only two factors it has is 1 and 2, 1 in itself. With 10, the factors are 1, 2, 5, and 10. So 2 is the greatest number that's shared between them. So our GCF is 2. Now, knowing that, we can simplify it and factor it so it looks like this. This would be the final factored form, and I'll show you why as soon as my pen and my marker loads. So this would be the essential, the factored version. Once you pull out your greatest common factor of 2 here, I know that 2 times x would give me 2x, and then 2 times 5 would give me 10. And if I wanted just to make sure that this was right, again, you can just kind of simplify and make sure that it looks like your original. Let's look at something like this. This is more like what you're going to see with polynomials. So if I asked you what the greatest common factor is for all three terms, 5x to the third, 25x squared, and 45x, what you're really asking is what is the greatest amount that you can pull out that's shared among the terms? So I know that if I've got 5x to the third, I know that I can pull out a 1 and a 5 and several x's. 5 is clearly going to be the number that we're going to pull out just in our like constant way. But if I've got x to the third, x second, and then just x, what's the greatest amount of x's that you can pull out from every single one? And hopefully you're telling me it's just 1x because you can't pull out more than 1 here. So your greatest common factor looks like this. It's just 5x because you can take that out of every single term and every term has enough to like spare that amount. Now, when you do factor this, we know that our greatest common factor is going to be 5x. Ask yourself before you set up your parentheses, all right, what do I need to add in here to get to 5x to the third? So right now, I've only got 1x. Essentially, all I need is just 2 more x's. So it'll be 5x times x squared. To get from 5x to 25x squared, not only do we need to multiply by 5, but I also need 1 more x. So it'll be plus 5x. And then how do I get from 5x to 45x? Okay, the x's are good. You don't need any more variables, but I know I need to multiply by 9. So it would look like this. Now, if you weren't sure, you can multiply this out and make sure that you're okay. So you've got 5x to the third power plus 25x squared plus 45x, and you're good to go. So last one, just to make sure. Okay, you've got 4x to the fifth minus 24x to the third plus 8x. Ask yourself not only what's the greatest numerical factor that you can pull out, but what's also the greatest variable that you can pull out. So I know I've got 4, 24, and 8. The highest number that I can pull out is 4, okay, because you can't pull out anything bigger than 4 from 4x to the fifth power. So we know it's going to be 4. And then ask yourself, what's the greatest number of x's that I can remove from each term to kind of get my GCF here? And I know that it has to be 1 because you can't pull out more than 1x from 8x here. So GCF, 4x. Now, figure out what you need to get to each term up here. So I've got 4x and then x to the fifth. Hold on. So I know to get from 4x to 4x to the fifth power, I need 4 more x's. So it'll just be times x to the fourth. To get from 4 to negative 24, I know I'll need to multiply by negative 6. And then to get from x to x third, I know I'll need 2 more x's. So all in all, it'll be minus 6x squared. And then to get from 4x to 8x, I just need to multiply by 2. So it'll be plus 2. Now to make sure, again, you can multiply this out to make sure that it equals your original expression here. So you've got 4x times x to the fourth, that gives me 4x to the fifth. 4x times negative 6x squared, that gives me negative 24x to the third power. And then 4x times 2 gives me 8x. So not only did you identify the greatest common factor here, but you also kind of consolidated into its factored form, which is in blue. So your assignment for today is an A2 Pearson lesson quiz. So that's online Pearson, it's not on Schoology. Do your very best. Thank you very much.